Hi, welcome to our second lesson in the polynomial functions chapter. Today we're talking specifically about quadratic functions, and as you'll recall, quadratics are a class or a family of U-shaped graphs that are symmetric about a line drawn straight through their vertex. The vertex is the point at the bottom. The line here is called the axis of symmetry, and axis of symmetry. It always is described by the x equals line that it goes through. So the axis of symmetry, and the one that's shown here is the line x equals 2. You'll notice that also means that an x of 2 is where you'll find the vertex in this function. In this one, opening upward, that means that the leading coefficient has a positive value, or the leading coefficient is greater than 0. In this one, the axis of symmetry is also the line x equals 2, and its vertex is at the top, which means that this one has a maximum value there. And this one, which I did not point out before, that vertex, since it's at the bottom, gives the minimum, or the smallest minimum. Gives the smallest y value possible right there at the vertex. There are some things that we'd like to add about properties of quadratics. The standard form for a quadratic equation, and this is specific to our textbook. Usually, if I were going to talk about a parabola's equation, I give what our textbook calls the general form equation. And the general form is ax squared plus bx plus c equals 0. If that's the case, I want to just remind you of something that we learned from a long time ago, and something that will help us today, is that you can find the x-coordinate of the vertex by using the little expression opposite of b over twice a. That works if that equation is in general form. Its standard form for a quadratic equation, however, looks a little bit different. You know what? That should not say a 0 up there. That should have a y or an f of x. I'm going to make it y. The standard form of a quadratic equation displays a little bit differently. It looks this way. Multiplier, perhaps, times the quantity x minus h squared, and then plus k. And the h and k in here, those are the x and y coordinates of the vertex. So the point hk is the vertex, which is kind of important. So when you see an equation in this format, and of course you'll remember from our transformations discussion several lessons ago, the value of a out here determines how wide that parabola is going to open, or how skinny it will be. It also tells you whether or not you'll be facing upward or facing downward. So the standard form shows you the vertex right off the bat, and that's one of the benefits of having standard form if you're graphing, because you can tell right away where that focal point, where the vertex is going to be. The general form can also be used to graph, as long as you remember that that vertex x-coordinate can be found by doing opposite of b over 2a. Also, this one will tell you the y-intercept, because that constant will be the y-intercept. So there are some tips for graphing parabolas. Let's continue, and we're going to use some of those things here. From what we said just a moment ago, you can tell that in this one, a is -1, and that means that we're going to be opening downward. The vertex in this one, here's h, here's k. The vertex in this parabola is going to happen at the point 1, 4. And that means that we're over 1 and up 4 on this. We know it's going to be opening downward, so it's going to end up down here. Now, as far as determining other points to plot, there are several things that you can do. To find the x-intercepts, the places where it crosses the x-axis, you set f of x or y equal to 0 and solve. And I'm going to do that over here on the side. Solving the equation, 0 equals the opposite of x minus 1 squared plus 4. Solving for x, I'd have to subtract 4 to begin with. 4 is equal to the opposite of x minus 1, x minus 1, quantity squared. Dividing both sides by -1 would give us 4 equals x minus 1 squared. To isolate x, you take the square root. So over here we'd be thinking positive and negative square root of 4. You got to consider both, equals x minus 1, and then add 1 to find those values for x. So the positive and negative square root of 4 is 2, plus or minus 2, and then we're adding 1 to that. I'm going to put that 1 out in front. Our our x-intercepts then will be 1 plus 2 and 1 minus 2, 3 and -1. And that, folks, gives us a way to get the downward trend on this. Now we know how it has to look. You can specifically find the y-intercept by setting x equal to 0 and solving. And I would do that as well for this one if x is 0. So I'm going to do that up here. Y will equal the opposite of 0 minus 1 squared plus 4. And as far as doing the work, 0 minus 1 is -1. -1 squared is 1, but we want the opposite of that. So -1 plus 4, y will equal 3, or this one will cross the y-axis at 3. Folks, because of the symmetry, I can also darken in that spot, and now I have a perfect pattern for my parabola. Opening downward, x-intercepts, y-intercept, and symmetry. All those things help us to graph that parabola by hand. Good. Here's one for you to try. I've asked you some leading questions. This would be a good time for you to turn off that video for just a moment, pause it, and see how you do. As far as how it will open, it's going to be upward, since the value of A is positive. The vertex, based on this, remember the normal equation has a minus in here, so this one has changed signs. That means our vertex is located at -2, -1. So -2, -1, there's the vertex. The x-intercepts, that means we're going to set the equation equal to 0 and solve, and I'm going to do that here. 0 equals 2 times the quantity x plus 2 squared minus 1. Add 1 to both sides, divide by 2. So I'm kind of putting some steps together there. Adding 1, dividing by 2. So 1/2 will equal the quantity x plus 2 squared. Taking the square root of both sides, so we're talking positive and negative square root of 1/2 equals x plus 2. And subtracting 2 from each side, minus 2 or -2 plus or minus the square root of 1/2. Now, you could figure this thing out using your calculator if you wanted to, but I'm going to say I think that finding the y-intercept will be a good way for us to track the pattern of this. So I'm going to go ahead and find the y-intercept by setting x equal to 0. Y will equal 2 times the quantity, 0 plus 2 squared minus 1. 0 plus 2 is 2, 2 squared is 4. 4 times 2 is 8, and 8 minus 1 is 7. So the y-intercept here is at 7. And you can see that's 2 steps over from the vertex. So on the other side of the vertex, 2 steps over and 7 up is where we will find another symmetry point for this parabola. And it's going to look something like that. Now, the x-intercepts, you can see, are centered at a line of x equals -2, which is just what this says. Both of them are the square root of 1/2 away from that line -2. And we've graphed those parabolas by hand. Good. Let's move on from there. This says, though, what if the quadratic isn't in standard form? And very often they're not. I think really this is the more familiar term. Recall from last year and just a moment ago that the x-coordinate of the vertex can be found with this handy formula. This is important, folks. Opposite of b over 2a. So if I want to graph this one, there are some things I know about it right away. It has a negative leading coefficient. That means that it's opening downward. Its vertex, well, I'm going to save that for a minute. I'll go back there. Its y-intercept is the constant here, 1. And we can find the x-intercepts using the quadratic formula. Or, again, that would just be setting y equal to 0 and solving this, this quadratic. Okay, so I'm going to go after the vertex next. And I know that the x-coordinate of the vertex is going to be, so I'm going to write vertex x up here. It's going to be the opposite of b, so negative 4 over twice a. A is negative 1, so that's over negative 2. And the x-coordinate of that vertex is going to be 2. To find the y-coordinate, well, we want to plug x of 2 into this equation and grind out a y. So y will equal the opposite of 2 squared plus 4 times 2 plus 1, and that is 4 but negative. So negative 4 plus 8, that puts us at 4. 4 plus 1, 5. Y is 5. Follow through that math and see if you don't agree with me there. 2 squared is 4. This makes it negative. Negative 4 plus 8 is 4, and 4 plus 1, 5. Here's our vertex at 2, 5. We're going to be opening downward, and we have a y-intercept of 1. So I'm going to plot that and say, again, I can use the symmetry here. That's 2 units from the axis of symmetry, so 2 units on the other side. This point is also on the parabola. That gives me enough to graph. However, I certainly can find those x-intercepts using the quadratic formula, and I will do that right now. X will equal, and it's the opposite of b over 2a. We've already done that part, folks. We know that that's 2. But I'll write it out just so that we don't forget. Then it's plus or minus, and it's the square root of b squared. b is 4, so we're 4 squared, or 16, minus 4 times a, which is negative 1, times c, which is 1. All of that over the over 2a, so negative 2. Okay, now we're going to simplify. X will equal 2 plus or minus. It'd be 16 minus 4 minus negative 4, so that's 16 plus 4. That's the square root of 20 under there. All over negative 2. And I'll tell you right now, the negative down here is really not going to have any effect since we're looking for both positive and negative. So the next time I write this, I probably won't write the negative 2 down there. The square root of 20, well, that's 4 times 5 in there. And you can take the square root of 4. So here's where we're looking. 2 plus or minus, the square root of 4 is 2. Root 5 is still in there. And, whoops, I want to be careful there. The fraction bar I'm going to write doesn't go under that whole expression because I've already done the dividing there. So it's going to be 2 plus or minus, and then it is 2 root 5 over 2. And those 2's cancel, so our x-intercepts are 2 plus and minus the square root of 5. Centered around the line x equals 2, and however far the square root of 5 is. Well, I happen to know that that's around 2.27, so it's going to be out here, right in there, and that's just a guesstimate. But it does follow the pattern that we're looking at before. So we graphed again that quadratic, even though it wasn't written in the standard form, by finding its vertex, looking for y and x intercepts. Good job. All right. The next thing on our schedule today is talking about maximums and minimums for quadratic functions. And you know that it's got to be true. If you have one that's opening upward, that point's going to be a minimum. If we have a parabola open and downward, then of course the vertex point is going to be its maximum. The shape of the graph makes it easy to determine whether you're going to have a max or a min. If the parabola opens upward, and that would be a, the leading coefficient, greater than 0, positive, then the parabola will have a minimum. It'll be at the bottom at the vertex, and this is the way we can find what that will be. Opposite of b over 2a, and then the value of the function at opposite of b over 2a. So you plug this value into the function to grind out the y that you need. If the parabola is opening downward, that would mean that a is less than 0 or is negative. There will be a maximum at the vertex, which occurs at negative b over 2a, and has y value of function at opposite of b over 2a. And then it asks us to find the max or min for this function. I'd ask you first of all, will it be a max or min? And I'm hoping that to answer that question, you're looking at the leading coefficient that is positive, so we must have a minimum here. This is a parabola that's opening towards upward, so minimum at the bottom. To find the minimum, what we got to do is locate where the x of it is. So the vertex x, and this is how I usually show that, vertex x is the opposite of b, so 16, because it was negative 16, over twice a, and twice a is 8. Our minimum happens at x of 2. To find the value of that, then we need to do f of 2. And let's see, 4 times 2 squared minus 16 times 2 plus 1,000. 1,000, what were they thinking? 2 squared is 4. 4 times 4 is 16. So here's positive 16. Here's minus, though, 16 times 2. So that's 32, and 16 minus 32 is negative 16. So we are negative 16 plus 1,000, and you can do that math, and I think I can too. That's going to be 990, let's see, 16 from 100, 84, oh, 984, 984. Okay, just check that out. I said that doing it in my head is not always good, so I'll write it out to the side. 10 minus 6 is 4. That makes this a 9. 9 minus 1 is 8. This has already been borrowed from, so yeah, 984. So the maximum, minimum value for this parabola happens when x is 2, but the minimum is 984. Very good. I hope that we reminded you of some things that you knew about parabolas. I hope that we gave you helpful tips for graphing them, and we will see you in class tomorrow. Have a good evening.